Hi everyone, welcome to the Data Scientist Podcast. I'm very happy to have here with us today Dharma Teja, who is a senior data scientist at Amazon with a very unique, let's say, blend of skills which include causal inference as well as econometrics. For those of you who don't know, causal inference is one of those areas in data science and AI which is really cutting edge, but most people are not aware of it. And I'm looking forward today to a very interesting conversation. Well, Dharma Teja, welcome to the show.
Hey, thank you for having me.
Would you like to introduce yourself and share a few words about your work?
Yeah, sure. Myself, Dharma Teja, I work as a senior data scientist at Amazon. My work or my expertise is like mainly in intersection of data science, statistics, and business economics. Mainly focusing on how organizations make like high-stake financial and product decisions using data. My background spans like all through forecasting, causal modeling, like ROI analysis, and other things. And the big part of my work is translating complex analytics into a clear, defensible business decisions that leadership can trust.
Fascinating. So can I get a better understanding of what your tool set looks like? And I'm not saying, like Python, things like this, but obviously from what I understand, what you're doing probably involves, let's say, many different areas from more vanilla analytics all the way to causal inference. So I'm trying to understand what kind of methods and models you use. Is it more like from the statistical side? I guess it's a combination, I'm just really curious.
Yeah. Yeah, like my day-to-day work includes many things, right from forecasting, of course. Yeah, Python is one of the language that we primarily use, and myself as well in this area. And when you specifically say about the skills or like tools or toolboxes we use, like of course for forecasting and other things, we kind of heavily use scikit-learn and some of the PySpark similar what we say the functions. But for causal models, we also have a specific causal analysis toolkit that both in Python and also in PySpark, depending on the place that we you do the analysis. And primarily, we code mainly in Python for all these models. And I specifically also like show some interest in R, and because they have specific statistical toolbox which I can combine with. But for a production level models, Python is always the one that I generally do.
Okay, yeah, that's fascinating to hear. And would you like to explain a few, in a few words, or maybe it's probably going to take more than a few words, what causal inference is? Because personally, I feel it's an incredibly important area in data science. It also, I think, touches a lot of very important aspects in AI. But I think that a lot of people, even professionals in the area, they're just really not aware of causal inference, which is really unfortunate. So I'm really curious, first of all, like if you could explain a few words, that would be one thing. Secondly, it would also be interesting, like to explain the importance, right? So how can someone use these methods in different contexts?
Yeah, sure. So let's like take a step back and just discuss a basic cause and effect model. Like if I'm doing something a particular action, the effect is something we expect something in return, right? So causal inference is something we kind of measure the value of a particular action caused by a particular action. So that's like a causal inference. Like if you say forecasting, that is basically trying to predict something in the future, like trying to understand what a particular action can bring like 5 years or 3 years down the line. You can try to use some regression and time series forecast models and try to understand how we kind of approach or what can the outcome be in some time. And the causal inference is something we can we can also take help of it to measure a what if scenario. So basically we implemented something, let's say in the past 1 year back, or we kind of approached, or we kind of released a particular product or a feature like 1 year back. We can understand what was the value of that particular feature in the last 1 year. So basically, to say what if scenario, it means, let's say if that particular feature is not existing, then what would have been our business outcome? Let's take a vague, real world example, like a Netflix. So now Netflix, for example, they started, let's say they started introducing this ads plan or something. Basically, previously there were no ads in between the video, and let's say they introduced, like a different plan where they kind of give ads in between the video or something, in between each and every video title. So if they wanted to understand what was the what's the business outcome, like in terms of, it can be anything, like it can be revenue, it can be customer churn, or it can be like the users that we how many people we were able to onboard more or lose the customer base or something like that. Outcome can be anything, but for us to understand what was the causal effect of that particular implementation, we can actually see. So basically, we implemented something in 1 year back, and this was the customer base retention, or this much the revenue that we generated. But what if scenario is something, what if the particular launch has not happened? Today would have been better or worse? To measure that, that is where causal inference comes into picture. So we need to understand a counterfactual problem where, hey, what if this particular thing is not existing in the real world? What would have been the actual, actual outcome of any particular outcome variable that we are actually targeting? The target variable, whatever it can be revenue or a retention or whatever. To measure that, we try to use the causal inference to understand, are we in a better position, or no, it has become worse, or we should take any directions.
Yeah. That's very interesting. And can I ask you, I remember I was studying causal inference a few years back. I don't know whether the techniques have progressed at all. It felt that Julia Pearl was, I think, one of the biggest names in the area back then, and he was working a lot in causal graphs. Obviously, causal graphs are not always, easy to build in certain areas. I think a lot of examples were related to medicine, where obviously there's more confounding factors, as we call them, that can affect this. Do you find the state of the art in terms of method, as well as libraries, like for those data scientists that want to pick this up, is it is it now better? What's the space like?
Actually, causal inference is one place where there is a drastic improvement over the years. So the one thing that has always been there, and it has been like very much improved and has become more stagnant, is like forecasting and prediction. But the causal inference models are generally very business specific, because identifying the correct counterfactual actually defines the whole the accuracy of the model or whatever. And the causal inference is a particular scenario where we don't have a definitive answer, okay, this is what is definitely would have happened if that particular thing didn't happen in the real world. We cannot actually say, because there are multiple things that can even come. For example, let's say a business like Walmart or Amazon, whatever, if they have done some, they have come up with some causal numbers for their business improvements, let's say in 2020, and things like COVID or something might have come. And introducing such effects into our model is very tough, like something like a COVID scenario, which changed the whole world, and the variables that actually affect in terms of such market scenarios is something, when I speak specifically in finance or even other places in the tech business, it is very tough to actually induce some kind of market scenarios where we can get more confidence in any causal analysis. But yeah, when we speak especially in terms of the toolkits and the different models that we have in causal modeling, it has improved a lot in last 5 to 10 years, especially with all these new business initiatives or models that have come, especially in the social media, and also the subscription-based models and many other things actually led so much experimentation and research in this particular field and has improved a lot. But yeah, again, the causal inference is something where we cannot be very assured that, okay, this is what is going to happen, and because there are multiple market scenarios that would affect in our analysis and experimentations.
So do you feel this is something that's, let's say, more relevant for bigger organizations and enterprises, or can also smaller businesses can work with this type of technology?
Yeah, that's a good question. So as big the business is, that much more the accuracy or the more better the causal models can be generally. But it doesn't restrict us to use for any small scale testing, because sometimes even testing in the small scale can give us much more better understanding, like A/B testing and other places. But again, when we think in a big perspective, the more the causal model can be very comparative to the real world is where the business as much more customer base and as much big the the business is.
Makes sense. Okay, and in terms of measuring economic value, right? So you mentioned econometrics. Obviously, we now talk about causal inference. So what I'm trying to understand is how does this fit into, let's say, the enterprise process, right? Obviously, this like measurement and data science, they're like incredibly important things, right? So we witnessed the big data boom 10 years ago, now witnessing the AI boom. There's certain, let's say, crossovers as well as synergies, even though AI is more about automation. But what I'm trying to understand is, in the end-to-end process, where does this fit in, right? So is it more of a, let's say, tool that decision makers can use to essentially make decisions around how to allocate resources, or is it something that, let's say, it's mostly for technical teams or areas like logistics?
Got it. So when we speak about economic valuation, it can spread across multiple things, because every business and every business and also every organization have multiple initiatives that they generally take into like every month or every year or so. So whether it's a big data boom or AI boom or whatever, different kind of booms come in the future, the one thing that always will be asked is whether these particular features or the new launches are economically viable or not in the long term and also in the short term. Basically, let's say now Gen AI is a very big thing, and many companies implement a new Gen AI tools and different things. But whether implementing such things into our business or into such features, is that economically viable for the business? Can it last long? That is where the main importance of the economic valuation or econometric modeling comes into picture. So it's like the process for like business initiatives or product launches. It requires a comprehensive analytic framework that generally combines both quantitative analysis with strategic considerations. So one thing to actually consider is when we talk about the causal inference, this is where this particular field actually emphasizes on. Whatever it might be the initiative, the causal inference models or causal models generally help us to understand implementing this particular thing, how much profitable it is to the company. And the second thing is, what if we didn't implement that? Because if we don't, let's say if we don't implement this Gen AI features or launches in our business, and the whole world and the whole other competitors are implementing it, so we don't have a way to measure how much we are losing our customer base because the other people are implementing it, but we are not. Because all the forecasting and everything we can do only on the data that we have inside the company, whatever company that we are working or whatever organization we are working, but we don't know how much customer base or revenue that we are losing because we are failing to implement such particular process or such particular products. So this is where causal inference or even econometric modeling generally comes into very big picture. And the main objective is like measurable and tying up to the concrete financial outcomes, whether it can be revenue, enhancements or operation efficiency or growing the market share or the user base, econometric modeling establishes a very good method for any organization to understand how we are succeeding in business. And having a good counterfactual scenario is very crucial generally, because unless we know the baseline, we cannot understand whether is this increment is coming just because of this feature or is this a natural increment. Because as the years go forward, as the time goes forward, our economic sense generally gets improved, like multiple countries or even in the same place that we live, everyone's spending habit improves, and also their capacity to spend improves, and it can be a natural progression of incremental revenue or incremental user base as well. But are we getting because of a particular launch? That is where another scenario where the causal modeling mainly helps. Whether it's a natural increment or is it because of a particular implementation of a particular feature or product. And advanced techniques like A/B testing and multivariant analysis also help validate some of the assumptions, and we can quantify some potential impacts. But the final step involves like translating most of these analytical insights into like mainly like measurable financial metrics, something like ROIs or NPVs, net present values or whatever, to understand how much we made some impact in the real world or and even in our own business or organizations.
That's very interesting. And do you find that AI can facilitate in this process? Obviously, we have vibe coding and all that, but for example, in areas like coming up with scenarios, coming up with counterfactuals, coming up with, let's say, using AI to do deep research on what the competition is doing and building multiple different types of models. What do you find there in terms of synergies between data science and AI?
Yeah, actually, when we think about when you say Gen AI, right? So basically, when we think specifically about Gen AI use cases, along with achromatic modeling, I can think of not just like helping it to improve the coding or make it faster for the analysts and statisticians, but the main thing I'm also looking into is like the clear defining of like treatment control definitions, for example, and the counterfactual scenarios, and especially the creating a synthetic data. So synthetic data is something very important, especially when we think about counterfactual analysis or any causal models. Most of the time, we kind of try to create synthetic data with different scenarios that we think that affects the business, right? But Gen AI can help in creating multiple synthetic data at the same time by turning on and turning off few of the variables that might or might not affect in different parts of different time frames. So like, let's say if you want to create a big counterfactual for last 10 years, Gen AI can actually help to create that synthetic data at different times, like during COVID or not during COVID, and let's say there is no COVID, and multiple scenarios, and then try to train the model. So this actually helps a lot in terms of having more synthetic data, which can also can be used along with the real data to better the causal models and econometric models.
Yeah, that's interesting. I think in terms of synthetic data, that's another area that I've done some work on, and then I think it's also a bit challenging because if you have, for example, data sets with a lot of variables, then you need to capture the relationships between the variables. A synthetic model can be fairly challenging to build. So I'd be curious to hear, when you can actually use synthetic data effectively and under what conditions. And I think that's going to be very useful also for people listening who maybe are in the entrepreneurial space, who want to, for example, they're like, hey, I want to create a model and I need to start from somewhere, and I don't know how to find a data set because, let's say, it's sensitive data, like medical data, financial data, whatever.
Yeah, synthetic data mainly used not just to create different scenarios, but also the times when we might not be able to use the actual data directly. So, for example, we have many restrictions in our real world for, let's say, healthcare, or even some of the financial orgs, where we cannot use the customer data directly. The reason for that is all the privacy issues and other places.
Yeah.
So that is where Gen AI can actually, help us to create some synthetic data. And it is not actual data or actual customer data, but it can create a synthetic data that can help us to improve our model, where because of the different HIPAA rules or many other particular rules, we actually cannot directly use some of the customer data directly, but we still want to improve our products to better help the customers and the users. So that is where the Gen AI and all the LLM models can mainly help in having a better synthetic data.
But do you find that you use synthetic data to, let's say, set up a model, maybe do a bit of training, and then deploy it, but then improve the model on real data? Or because essentially what I'm asking is, how would the process work in practice? For the simple reason that if you use only synthetic data, then you might have a model that's somewhat brittle, right? So at some point you need to find the right way to bring in real data into the mix. The challenge, I guess, with many of in some of those cases is that you don't necessarily have the ground truth, or the ground truth might actually arrive with a certain degree of delay, as it can often happen with areas like credit score or clinical outcomes. So what do you do in those situations?
Oh yeah, so it's very important to use as much as real data along with the synthetic data, because we don't want to have our whole assumptions based on some other assumptions, right? We don't want to just build our models just based on the assumed data instead of the actual real world data. So that is where we need to be very careful in using the synthetic data. But I would also say that having synthetic data alone is not generally always a better option, because most often or not in econometric modeling that specifically I was talking into, and also the causal models, we kind of get only one target variable most of the times, and just it's like mostly a one word or like a one sentence answer, whether our situation is better or whether the situation is worse if that particular thing is not there, or how much, if we say like by how much. This is the second scenario that we generally try to answer, and we don't try to answer a regular intervals using any causal models. So our is like, okay, if we implemented this, if we didn't implement a particular thing, we wouldn't have raised like $5 billion or for $10 billion or $15 billion. It's like a one sentence answer that we try to generally answer. And synthetic data is generally helping us to just give that bridge. Let's say if you use only real world data, we might end up saying a $5 billion or something, a feature is actually valued, or a particular product. But by using synthetic data, we can understand, oh no, there are few scenarios we might have missed, and it is only 4 billion or 3.5. By introducing this synthetic data, we are observing a big difference, like 1 billion or even a 10 billion. So that means to say that there is a lot of noise in the synthetic data itself. We want to support the real data with some synthetic data scenarios where we can adjust that little edges, but not just rely heavily on the synthetic data that actually affects the real world cause and effect matching that we are trying to do.
Yeah, makes sense. So I guess it's a bit of a case-by-case basis, right? And it can also be influenced by the distribution of the target and things like that. Okay. Yeah, let's move on to something else. So in terms of, let's say, AI and data science, how do you find that recent advances in AI have affected data science? What I personally find interesting is that vibe coding has made us more productive. At the same time, I remember people, which obviously they were, maybe. This comes with every technology, right? So when ChatGPT first burst into the scene, there were people saying, now everything's going to be AI and this and that, which is obviously not the case. So what's your take on this? How do you find that the AI, the advances of the last few years here affected the data science space?
Yeah, so data science field has always been like a growing field from many years now. And so with the effect of AI, I would say the data science field has actually made it much more accessible to use the data science models, even for the people who are like lesser in terms of background in terms of data science, or like in terms of technical day-to-day skills that they have. So basically now I could see like if we want to creating a big forecasting model of a revenue of a business or something like that, previously we used to run multiple models in many tools like SageMaker or many other places for us to understand. We need a proper technical guy with the data science knowledge to actually run whatever the Databricks jobs or whatever. But now I would say even like a non-technical product managers or someone who actually want to build products very in a particular direction, but they don't have enough help with the data scientists or data people who know some data science models. They can still take advantage of the latest implementations of AI and data science combined tools. Like for example, Amazon has this Quicksuit or something like that, where you can easily have the past data and everything, and you can try to explain what kind of scenario you are thinking, and it can actually get you a forecasting models without even requiring a complete data scientist or someone. Of course, they may not be able to directly use every time such things into their production, but at least they give them a direction at which if they're trying to build a thought product, they don't need actual data scientists to actually do some scenario testing. If using these AI tools, which have much more data science capabilities, they can actually build some level of product directions. And if they're really going ahead to implement that in real world and trying to get more profitability out of it, then they can actually go and hire people with the data science skills and do more things like this causal models or even other models. But they can easily skip that primary stages where they actually need data scientists to even evaluate a product or its viability in the future. And it helps not just in that small thing, but even in the many things in a broad setting on a day-to-day level. They don't need to, not just the product managers and many people, they don't need to actually depend on actual data scientists to answer many questions, like in terms of a simple scenario question. Previously, they need a person who actually owns this particular whole architecture or something to go and do, but now they don't need that particular skill set. They can actually depend on these small things. So it actually improves the time of all the product people and even the data scientists, because previously they spend all the data scientists, including myself, we spend a lot of time in data cleaning and other things. Now, which can be much more. So there is this saying that 90% of the data scientist time just goes on cleaning data, right? So basically, they take a lot of time in making a proper quality data. And the data quality has improved a lot by introducing these LLMs and Gen AI tools. That the time that I spend on the data quality improvement reduced from 90%, for example, to say to 30% or 20%. So I can use my actual the data science rigor and the skill that I have to actually build a better models and reduce the time on just spending the time to clean the data or something like that. So it improves, even it is good for even the data scientists as well, because they kind of try to do more research and improve the things that are really required for the product and the field than actually spending time on things that improving the quality of data or something, which now can be easily done with AI and other tools.
Yeah, makes perfect sense. So you feel that nowadays maybe decision makers need to acquire, maybe data science has become more accessible, and maybe that's another skill that maybe decision makers and managers can acquire, not necessarily being technical, but maybe knowing how to ask these types of questions, because it will also facilitate the end-to-end process. And it's not like, I guess, about necessarily replacing, data scientists with, suddenly the manager, the executive does this work, but I guess it can help steer the project in the right direction.
Yeah, agree.
Perfect. Okay, so I think, we're reaching the end of this episode. Before we go, where can people learn more about you? Like a LinkedIn profile, personal blog? If anyone has any questions around, AI, data science, causal inference, where can they learn more about you?
Yeah, sure. I can just share my LinkedIn profile, and also I'm an active mentor on ADP list as well. Many people just send requests, and I am very happy to speak to them on weekends. It's a very good platform for mentoring people and even learning from other people. So that is one place I kind of very actively help people, and I can share my LinkedIn profile and everything, which you can actually use it in the blog or wherever you post it. That's perfectly fine.
Perfect. Thank you, Dharma Teja. It was a very interesting episode.
Thank you. Thank you very much for having me. It's really interesting.
Yeah, thanks for everyone for sticking with us. Make sure to check the datascientist.com and our YouTube channel for more content. Thank you and hope to see you again soon.
Yeah, sure. I'm a continuous contributor on the Data Scientist as well as the AI Journal, which is like your partner website. So definitely I will take some time for
Perfect. Excellent. Thank you, Dharma Teja. Thanks, everyone.
Thank you. Bye-bye.